Hi, this is Mike Lopez, and in this video we're going to be looking at the quadratic form of partial fractions. Okay, let's have a look at an example. We can get into this form in more detail. How about 4x squared minus 2x plus 5? Well, sitting over, let's stick a linear factor in there, shall we? And then we'll put in a quadratic factor. X squared plus 4 is a quadratic, of course. Okay, so what we're saying is, the highest level here is a quadratic form in this denominator. And if you look in your workbooks, it gives you a table of standard partial fractions and types, and the solution here is going to be of the form a over x plus 1 plus bx plus c over x squared plus 4. Okay. And of course, a, b, and c are constants, or numbers if you like, which we need to find. So, as we've done in previous videos on partial fractions, what we're going to do is take hold of this denominator on the left here and tag it as star, and then we're going to multiply all the numerators on the left and the right, or the tops if you like, by that star. And you've seen this done a couple of times now. So what transpires is 4x squared minus 2x plus 5 is equivalent to a lots of x squared plus 4. It's more like a 3. It's supposed to be a 2. Ax squared plus 4 plus bx plus c lots of x plus 1. Okay, and that's going to be very useful to us, so I just got enough space here and call that expression 1. Okay, so what can we do to find a, b, and c? Any ideas? Well, if you've watched the previous videos on partial fractions, you know about letting x equal 0. Does that help? In this case, not really. Making one of the brackets 0, well, that one is x squared plus 4, so that's going to end up being, well, we want x squared to be minus 4, so that's not good to us. That's going to end up with complex numbers. This one's got 2 unknowns in, so we can't do anything with that one. This one's got x there, so we could make the bracket 0, so x is going to, of course, be minus 1. Okay, so we can say let that end bracket equals 0, therefore x must be equal to minus 1. Okay, so then we're going to look at expression 1 here that I've marked with the square brackets, and we're going to replace x with minus 1. Okay, let's do that. Therefore, 4 lots of minus 1 squared minus 2 lots of minus 1 plus 5 is equivalent to a lots of minus 1 squared plus 4. And I don't need to write anything else for this lot because minus 1 plus 1 gets you to 0, and 0 times all that bracket gives you 0. Okay, so this is a good expression for us to analyze now. Okay, let's simplify things a bit more. Minus 1 squared gets you to 1, so that's just 4 Minus 2 times minus 1 is plus 2, plus the 5 equals, let's change to equals now. Over on the right, I've got minus 1 squared, which is 1 plus 4 gets you 5, so that is 5a. Therefore, 4 plus 2 is 6, plus 5 is 11, is equal to 5a. Therefore, we know what a must be. A is 11 over 5, which we can just keep as 11 over 5, or if you wanted to, you could say it was 2.2. Okay, we'll keep it as 11 over 5, which is quite handy in circuit analysis in engineering. Okay, so what can we do now? We've had a look at this bracket. We've made x equal to minus 1. We can't really make any other brackets 0 easily. Making x 0 isn't going to help us much either. So this is where we come along, and if you check in the workbooks, you'll see something about equating coefficients. And that's exactly what we're going to do next. So I'm going to equate coefficients of x squared. And what that means is we're going to look at expression 1, and all we'd like to do is to work out what the coefficients of x squared terms are only, and ignore everything else, and we end up with a brand new expression. Okay, as you'll see and explain now. So the way we write equate coefficients of x squared in shorthand is this: an x squared into square brackets and then just place a colon. Okay, so that's normally shorthand accepted as equate coefficients of x squared. And let's see if we can do that. Maybe I could change colours again, make this a little bit more readable. Okay, so I'm looking at expression 1 here. I'm looking at this first term. Maybe I can put a circle ring around that. Okay, I'm looking at that. Is there a coefficient of that in terms of x squared? Okay, so yes, the thing that multiplies x squared here is the 4. Okay, so I'm going to put a 4 in. Okay, if you look at this thing here, that's nothing to do with x squared, so we ignore that. Looking at this, that's nothing to do with x squared, so we ignore that. Let's put this equivalent sign in, or equals. Okay. Anything over here to do with x squared? Well, that times that is a x squared, so it's a lots of x squared. So a is the coefficient. It's the thing that multiplies x squared. This times that gives you 4a. That's not in the x squared family. Moving over, this times this gives you bx squared. So it's b lots of x squared, so plus b. Right. That times the 1, that just gives you bx, nothing to do with x squared. That times that just gives you cx, again, nothing to do with x squared, and that times that just gives you c. So again, nothing to do with the x squared family. So what we've managed to find out here is that 4 equals a plus b. Okay, but just above here we've already determined a was 11 over 5, so we should be able to therefore determine what b is. Okay, so I can say therefore b equals, I'm going to move the a over to the left hand side, and it's going to be 4 minus a equals, well, it's 4 minus 11 over 5. Now it would be useful if we could express that 4 as something over 5. Well, 20 over 5 comes to mind. Okay, so 4 is the same as 20 over 5, but we write it in that way because it's now easy to take 11 over 5 away. And of course we end up with 9 over 5. So you can say, therefore, maybe I should change back to red. Therefore now we can say B equals 9 over 5. Okay, and shade it in the same colour as we did for A above. Okay, so what do you think we should do next? Well, we've just found an expression by equating coefficients of x squared. Maybe it's a good idea now to possibly equate coefficients. Have a guess what I'm writing. Of x, or x to the 1 if you like. It's the same as x. So we're going to equate coefficients of x. So we're going to do the same thing as we did previously, but we're just treating the x family now rather than the x squared family. So coefficients of x. Right, and let's see if we can grab those. Again, look at this expression 1 over here. First term drops away. I've got a minus 2 lots of x. Nothing else on the left is equal to nothing between a and x squared and a and 4, so that drops away. This bx times x is x squared, so that's nothing to do with x. However, we have a bx times a 1, which is, okay, so it's just going to be bx times 1 is just bx. And so the coefficient of x is b. And we also see a cx here, this one. Okay, the c times the x. Okay, so the coefficient of x there is c. So we end up with minus 2 equals b plus c. Now, we already know what b is. Okay, we know that. We've already determined that to be 9 over 5, so therefore we can find c. Okay, so you're going to say c equals minus 2 minus b, which is minus 2 minus 9 over 5. We express the 2 as something over 5, it would be handy. And we get this minus sign. Okay, something like 10 over 5 is 2. Minus 10 over 5 minus 9 over 5. That's going to give you minus 19 over 5. Okay, so we can therefore say in red c equals minus 19 over 5. And I'll just ring that in pink. And then it appears that we have our proposed answer. Okay, so the answer is, well, let's put the question in first of all. 4x squared minus 2x plus 5 all over x plus 1 times x squared plus 4 can be written as, okay, we've got a, and we've already determined a to be 11 over 5. Okay, so we could just write then 11 over 5 sitting over x plus 1, in brackets if you want, plus bx plus c. Well, b is 9 over 5. 9 over 5x plus c. Well, c is minus 19 over 5, so plus minus gets you to minus 19 over 5, and all that lot sits over x squared plus 4. And again, you can check this by reverse engineering this thing here. Find a common denominator, multiply out as normal, as you've seen in the previous two videos. And I think you will confirm, because this has been triple checked, that the answer is indeed correct. Okay, thanks for watching and see you next time.